Hey everyone, welcome to another episode of Let's Lead. आज की जो हमारी प्रॉब्लम है that is number of smooth descent period of a stock, right? It's a kind of two-pointer problem and a bit of maths, but it's pretty much easy, I would say, right? The problem says you are given an integer array prices representing the daily price history of a stock where prices I is the stock price on the day. A smooth descent period of a stock consists of one or more contiguous days such that the price on each day is lower than the price on the preceding day by exactly one. The first day of the period is exempted from this rule. Return the number of smooth descent periods, right? An example is given. Is what the problem says is the stock prices are given 3, 2, 1, and 4 on a particular day, right? And let's say if this is day 0, this is day 1, 2, 3. A smooth descent period is when the stock price fall exactly by 1 in the next day. So on the first day, let's say it was 3, the next day it was 2. So that is a descent of 1, right? And from 2 it is 1. This is a descent of again 1. Now from 1 to 4 it's not a descent, so it's not a smooth descent, right? Now we need to return the number of smooth descent period. So from here to here, 3, 2, 1, there were three values where descent happened. Now it can be 3 comma 2, this is one descent period. It can be 2 comma 1, this is one descent period, as well as 3 2 1, it's one descent period. So 3 2 2 1 3 2 1. Now these are 3. Again, a single values in itself is a smooth descent, right? Here, in example, you can say, note that a period with one day is a smooth descent period by the definition. So, according to definition, even a single value in itself is a smooth descent. So, 3, 2, 1, and 4, right? So, we can say total number of 7 smooth descents period, and that is the answer. Let's take an example, right? Let's say I have 4, 3, 2, 1, and then there is another period of let's say 9 and 8, right? Now, understand this. What we can, if we somehow identify the total smooth periods, for example, one period is this 4, 3, 2, 1, and then one period is this, right? Now, understand this. This can be one group, this can be one group, and this can be one group. This altogether can be one group, and this altogether can be one group, and this whole can be one group, right? Similarly, this can be one group. Now, in the example, it was said, and in the question, it is said, it itself, a number it in itself is a smooth transition, right? But let's forget about this right now. Abhi, if we need to calculate somehow, if we get the periods, let's say, somehow, then how can we get the total number of smooth transition? Like in 4, 3, 2, 1, the groupings that can be done is 4, 3, 3, 2, 2, 1, 4, 3, 2, 3, 2, 1, and 4, 3, 2, 1. That is 1, 2, 3, 4, 5, 6. What I mean to say is, let's say 4 यहाँ पे अगर आप देखोगे 4 किसके साथ ग्रुप बना सकता है? 4 can be grouped with 3, 4 can be grouped with 4, 3, 2, 4 can be grouped with 4, 3, 2, 1. I mean in total 4 types it can make group. 1 with 3, 1 with 2, 1 with 1. Right? Now, again, if we look into this, sorry, this is 3 type. Total in 3 types. Again, it will look into this. In how many ways can it make groups? One with this, one with this. In total 2 ways. If I talk about this can make with group with this. So total 1 way. And then itself it's 0, for example. Right? Because we are not counting in itself right now. Just forget about it of a single value. So total 3, 2, 1. 3, 2, 1. If we add all this up, it comes out to be 6, right? If you look into this. So basically, if we count in how many different ways it can be used and we take a addition, it will give me the total ways it can be grouped. And if I just add the single values in itself like 1, 2, 3, 4, it will give me the total ways this particular period can be made. that is 10, right? Now think about this. This is what is here that I am doing. It is the sum of n numbers. The formula was n minus 1 by 2. And how I came up with this is n minus 1 n minus 1 by 2. That is 4 was here, right? 4 was already here. So if I know the number of values within that period, 4 was there. N minus 1 is 3 by 2. If I do 4 times 3 is 12 by 2, that is 6. I know that this will make 6 total combinations, plus I just add the single values or the length of the subsection. That will be 4. So there will be total 10 combinations here. Similarly, I can do it for here. 9, 8, it will come out to be 3. So this will be total 13 smooth transition periods. Right, and you can try it with anything. Let's say if it 5 4 3 2 1, now this will make combination with this will make with this again, this and then this. So it will be nothing but, if you take a count, if you do a dry run, it will be nothing but n minus 1 by 2. And that is, here 5 is for example, if this could be anything. It's not like we are doing like 5 4 3 2 1. It can be like 100 99 98 97. So these are 4 smooth transition periods, right? So I can just do 4 into 3 by 2. That will come out to be 6. Similarly here it will be come out to be 5 into 4 by 2, and this will be 10, right? And then we just need to add the values, single values in the, or the length of the arrays. That is here, for example, 5, it will be 15, and here it will be like 6 plus 4, it will be 10. So this is how it will work, right? Let's quickly implement this. It will give you a more good idea on how to how this thing works. Now how we can work on this. For example, what we can do is to basically identify the sections. Let's say this is my section. I'll use a 2-pointer approach. I'll take a left pointer here, and then I can start a right pointer from here and do a difference of the left and the and then do a difference of the right pointer and the right minus 1 pointer value, right? And if it is, let's say, 1, the difference is 1, exactly 1, I can move to the right pointer to the next one, and then I can do a difference of, again, right pointer, right minus 1. And let's say if I come here and I see that my value is not smooth transition with r minus 1. What I can do is I can take a count of left pointer and the r minus 1 pointer, right, index, and store it somewhere, or do a calculation on top of it, and then move the left pointer to the new right pointer, right? Let me implement this. It will give you a more good idea. Let's say I'll make the left pointer as 0, right? And then I can do a length array. We can obviously make the code look much more cleaner, and probably we can do certain improvements, but let's keep it readable right now, right? And then I can do answer. I can initialize the answer. I can do an addition of the array length at the last, or what I can do is I can simply initialize my answer with the array length, right? So what I can do length prices. What I mean by that is, let's say my array was this, right? I know the single values will anyhow form a part of the smooth transition period, right? So instead of adding them in the periods, let's say 3, I add once and then I do a addition 4, I can start off by initializing the answer with the length of the prices itself, right? Or the length of the array itself. Now I start a right pointer for r in range, right? I'll start from 1 and then I'll go len of prices, and then I'll say if prices r minus 1 minus prices r equals to 1, then what I can do, r plus equals to 1. Right? I move the right pointer. Else, what I can do, else len array dot append right pointer minus the left pointer, right? And then I need to make sure that I set the left pointer equal to the right pointer. And in the end, for L in len array, right, what I need to do is answer plus equals to L into L minus 1 by 2. So why we are basically doing this is the sum of n values, n into n minus 1 by 2, right? And then when we have this, we can do return answer. Now let me run this. You think this is complete, but this is actually not complete. We'll get an error. Why do I get an error is, first I'll run this and then I'll show you for which test case it is actually failing. Now it fails for this particular test case. Let me write the test case here. Right. This looks like this, right? What is happening is, if you see, there are 3 periods here. First period is this, second period is this, and third period is this. Now, what happens is, if the right minus 1 and the right pointer difference is equal to 1, it increases. Else, if the difference is not equal to 1, what happens is, it moves to the else block and it is appended. Basically, the right pointer 1 is appended and the left becomes to right. Now what is happening here? Let's say the pointer starts from here. As soon as it comes here, here, and as soon as it moves to this pointer, it observes the difference is not 1. Then it stores the length of this array and the left and right pointer come here. Now again, they start a movement, right? Left pointer here, because the difference is not 1, it moves here. Now they start a movement from here. Again the same thing happens. They start a calculation, they go till here, and as soon as they reach this 10, they observe the difference is not 1. It moves into the else block, right? And then it appends and the left and right pointer come here. Now when they start moving, they move, and as soon as the right and left pointer right pointer reaches here, nothing is present, and the array is like like it's the end of the array. This condition is never met. It basically just matches. It comes here, it matches that, hey, 7 minus 8 is 1, okay, nothing happens, and it terminates. The loop terminates. This condition does not come here. So what is happening is, I only store the length of these two subarrays until here and until here. This one subarray length is never stored, this last one, right? And this gives us an issue. To counter this, what we can do is, we can simply do, after the r minus 1, if r equals to len of prices, that means that r has reached here, right? The right pointer has reached here, right? We can simply do len of array dot append r minus l, right? As simple as that. जैसे ही, as soon as the right pointer reaches here, we just do r minus l, and even in, let's say, in some condition r and l are at the same place, this will append 0 to it. And when we do this, basically the sum of 0, it will be 0 into 0 minus 1 by 2, and that will give us 0 itself. So this condition we just had. Right now, if I submit this, it completes, right? So this was the problem for today. It's simple. It's just, if you remember the formula for the sum of n numbers, it's easy, and two pointer question, right? Thank you so much. We'll meet next time. Please like and subscribe.